Hi everyone, my name is Tri and this is my student ID. And that is Tam. He is my group mate for this assignment. That's his student ID. Okay, so together we'll be presenting our network topology in Cisco Packet Tracer. For this project, I'll be using the private class C range 192.168.1.0/26, and I'll be subdividing it as follows. The subnets in gray are the ones that we'll be using for the assignment. The ones in yellow are the ones that will be free and can be used in the future. Okay, so I'll be explaining why I'm using these specific CIDR masks. For subnet A, I needed one for 8 hosts, so I chose the /28 because it provides 14 usable IP addresses. This gives just enough room for 8 devices, plus router interfaces. Now, about subnet B, C, and D, these only require 4 hosts each, so I used a /29 because it has 6 usable IP addresses, which is perfect for 4 end devices, plus network and broadcast addresses. Now, in subnet C, I'll be adding an additional web server, which still fits well because 4 plus 1 is 5, which is still less than 6, right? So it still fits within the /29 range. Now let's talk about the router interfaces real quick. Now, we'll be using a /30 network for each of the subnets. The router-to-router links only require this much because there are only 2 devices that need the IP addresses, right? So a /30 subnet has 4 IPs total, with 2 of them being usable. That is perfect. So let's demonstrate the connectivity of this topology in Cisco Packet Tracer. Now, first, I'll be pinging from subnet A to subnet B. Now, keep in mind, the first ping may sometimes fail. Well, it usually will fail across subnets, so we just have to try. Yeah, the second ping onwards should be successful. Okay, let's try from subnet B to subnet C. If we retry it, it is successful. Now let's try one last time from subnet C to subnet D. All right, and it is successful. All right, so now that we've covered the basic topology, let's go over the VLAN aspect of it. With the approval of Dr. Ushik, I have divided subnet A into 2 VLANs, right? The first VLAN is VLAN 10. Its range starts from 192.168.1.0/29, and VLAN 10 is for the second group of 4 hosts, by the way, using 192.168.1.8/29. Now, to enable communication between VLAN and the rest of the network, I used a technique called router on a stick, just like the example provided by our tutor in the Teams channel. Now, let's go back to Cisco Packet Tracer real quick. Instead of using multiple physical interfaces, now let's try hovering over the switch. Hovering over the router. Yeah, as you can see, I'm using 2 sub-interfaces on this router. Okay, so gig 0/1.10 is for VLAN 10. Gig 0/1.20 is for VLAN 20. The switch port connected to the router is set as trunk, which is important because it allows for both VLANs to pass through a single cable. Now let's demonstrate starting with intra VLAN, which is within the same VLAN. So let's ping from VLAN 10 to VLAN 10. It should be successful, but why? Okay, as you can see, it is successful. That's because there's no router involvement needed. The switch handles this traffic. Now let's try inter VLAN, which is across different VLANs. Now let's try again. Yes, it is successful. That's because we have the router interface enabled right now. It should succeed, right? But let's try disabling it real quick. If we shut down the interface, then what happens? Okay, so let's try picking intra VLAN real quick from 10 to 10. It is still successful. Why? That's because hosts are in the same VLAN. They don't need the router. They communicate directly through the switch itself. But what about from VLAN 10 to VLAN 20? Let's try pinging from, yeah, okay. So as you can see, it's failing. But no matter how many times you retry it, it's still going to fail. But why? That's because router interfaces is down, so packets can't be routed between them. Inter-VLAN traffic requires layer 3 routing, because if the trunk interface is down, no routing can happen, so the communication between VLANs will fail. Now that I've finished covering the VLAN aspect of this assignment, I'll be passing the mic to my friend, who will be covering task 3 and task 4.
Okay, hi, my name is Tam, and now in my section, I'll demonstrate task 3, which is layer 3 evaluation. So let's move back to the Cisco packet right here. So first of all, I want to ping from the BC16 to the BC1 right here, from subnet D to subnet A. Okay, first I want to clear the F. the app table. Oh, sorry. The reason why I clear the app table is to ensure the fresh address resolution. So let's try to ping to the BC1 to 68.1.2. Okay. We all know that the first ping between hosts in different subnets always fails because of the time it takes to resolve the MAC addresses of the default gateway and the destination host via app. So let's take a look. Let's take a look right here. Reply from this is the IP of the BC1. So the ping succeeds, indicating the connectivity between subnet D and subnet A. Okay. So let's move to the simulation mode to view what happened when I ping right here. Okay. So in this one, from BC 16 to the switch named Tam4. So as you can see right here, here is the source MAC, which is the BC16 right here. The destination MAC will be this one, the Tam4, which is the switch. Okay, and from Tam4, it will be sent to 3.1. 3.1 is the router right here. Okay, the switch forward to the router 3.1, right? So at the 3.1, the layer 3 IPs remain the same, as you can see in the screen. But the 3.1 router resolves the next hop MAC via app. So the packet access the gigabit Ethernet 0.1 in here, right here. I'm sorry. 0.1 right here. With new layer 2 MAC addresses. As you can see, the layer 2 MAC address change, reaching the BC1 via Tam switch. So let's explain a bit about this change. The ping worked because the router 3.1 use layer 3 IP addresses to route between subnets, right? While layer 2 MAC addresses change at each hop. The app table was rebuilt during the ping to map IPs to MACs, enabling delivery. So the router interfaces are the key for inter-subnet communication. Okay, so then let's move to task 4, web server configuration. So let's switch to the real time again. Then check the server. Okay, the HTTP and HTTPS is on. So I want to try ping from the server to on the device in the other subnet. Okay, try to ping this one. Okay, successful. They are all successful. So the successful pings from subnet A, B, C, and D confirm the server is accessible from all the subnets, right? If you want to try that ping from all the server, ping from all the subnet to the server. Okay, let's switch to the simulation mode. Try to ping from the BC8 right here to the server. Let's see what happened. Okay, expand a bit. Okay, in the BC8 tree right here, here the encapsulation, the ping start at layer 7 application with ICMB moves to the layer 3 right here with IP headers and okay, and IP headers including short IP and dash IP, as you can see right here. Let's see the IP of the BC8, and this is the IP of the server. Then in the layer 2, it will add in the MAC addresses. Okay. Then from BC8 to the switch Tam2, the Tam2 will process the layer 2 headers, update the destination MAC to the next hop, which is tree 2 right here, and forward the frames. The tree 2 then receives the frame, strip the layer 2 header, and checks the layer 3 IP addresses. I mean the layer 3 IP destination. Yeah. Which is this one is the server, right? Yeah, the server. Update the MAC addresses right here. So then the tree 2 right here send to the tree 3, and tree 3 will send to the thumb tree. So in the thumb tree switch forwards the frame to the server right here, based on the destination MAC in the server. We can see here is the encapsulation. At layer 1, thumb server receives bits and converts them into frame. At layer 2, thumb server removes the Ethernet header, which is the layer 2 header, and pass them to the layer 3. Layer 3 then header. And we can see the server can see the ICMP echo request, then repair for an echo reply right here. So thumb server is accessible due to correct IP and routing setup, right? The outside model shows the data encapsulated from layer 7 to layer 1 at the center, which is the BC8, and encapsulated from 1 to 7 at the server, ensuring communication. So I think that's the end of my task.
All right, so thank you so much for paying attention to our presentation. We hope to hear back from you. Oh, and there's a tiny Easter egg. We have a custom HTML file made in the web server. You can try accessing via each host's, like the different hosts' web browsers,
Okay.
and you can see it. We can try it right now, actually. Can you go to the web browser? Yeah, and then enter the address, yeah. So in this custom HTML file, we have detailed our topology here.
Oh, sorry, we need to re-time that being again. Okay.
Yeah, as you can see, that's the topology. All right, so thank you so much for taking your time to review our demonstration. We hope to hear back from you guys soon. Bye.